Welcome back. This is Mr. Hassan's Maths channel, and this is now question number 2 from the International A-Level Pure Mathematics P2 June 2022 exam from Edexcel. And this is another one of those typical questions that does come up now in the new specification for P2. It's about the trapezium rule, and the first part of it is pretty straightforward. Just basically, they've told us that figure 1 shows a graph of y equals 1 minus log to the base 10 of sine x, where x is between 0 and pi. So here we got to take care, because you can see that the angle is in radians, as they also tell us over here. So we have to take care of that. That's very important, and that's a place where potentially people can really mess up. Make sure that we use radian mode in our calculator, because we're using trig ratios here. So the table below shows some values of x and y for this graph, with values of y given to 3 decimal places. So part A is just simply to complete the table, giving the values of y to 3 decimal places. So we have to simply substitute, instead of x, the number 1 first, and then the number 2, and fill in the y values. But we have to make sure that the calculator is in radian mode. So right now it's in degree mode. So I must go press shift and set up and angle unit and number 2 for radians. So now it's in radian mode. As you can see, there's a little r there, and we can now proceed by substituting the values in here. So we have 1 minus, now it says log to the base 10. Now we don't need to use this button. We could do, if you want to, put log to the base 10 of 1, but there's a button here which means log to the base 10. Okay, if you write log without anything, by default it's to the base 10. Okay, that's how all logs were written before, in the calculators anyway. So log to the base 10, as I said, you don't have to write 10, okay, because that means log to the base 10, sine of 1. Close a bracket for that, and close another bracket for this, and that will give you your value, which is 1.0749. We want that to 3 decimal places, so 1.075. So you have 1.075. They want it to 3 decimal places. And then we do the same thing with the number 2. So I can just go back and change this to a 2. And we end up with 1.041. 1.041 to 3 decimal places, 1.041. So there we have part A. Very simple, but just take care that we have to use radian mode, because we're using trig ratios and the angles are in radians. Now it says part B, use the trapezium rule with all the y values in the completed table to find to 2 decimal places an estimate for the integral between 0.5 and 3 of this, same expression basically that produced this table. So basically we need to find the area. Basically that's what, when we integrate, we're finding the area under the curve between 0.5 and 3. Okay, and we can see this is like 1.3 going down, down, then going back up again. So it's like, just say something like this. All right? So say this is 0.5 and say this is 3. So basically we need to split up this into a number of trapeziums. The number of trapeziums are going to be the number of gaps between these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 trapeziums. That's what we're going to have here. So you're going to have 0.5 to 1. You're going to have, that's going to be 1. Then you're going to have 1.5. You're going to have 2. You're going to have 2.5 and 3. It's supposed to be equally spaced, but this is just giving you an idea of what's going on here. So this is 0.5. This is 1. 1.5 to 2.53. That's what you're doing when you are using the trapezium rule. We're splitting up this area into a number of trapeziums, okay, as we can see from this. And each trapezium, we know the area of a trapezium is equal to the distance between the parallel sides. Now these are the parallel sides going up, so the distance between the parallel sides is 0.5, which we call h. Okay, that's the distance. It's like the difference between the x values in our table is the h in our formula for the trapezium rule divided by 2 times the sum of the parallel sides, which are these lengths here, a plus b. So we have 1, 2, 3, 4, 5 trapeziums. All right. So the trapezium rule is basically based upon, as we said, splitting this up into separate trapeziums. And what we can do is, if we apply this formula to all of these at the same time, basically what we see is the h is common for each of these. All right, so you can take that as a common factor. H over 2 is common. Okay, and then we have the values. Okay, the a and b are the lengths of the parallel sides, which are the y values that you get from your table. So when x is 0.5, y is 1.319. So that's the value up here, 1.319. That's how long this is. And when x is 1, y is 1.075. Okay, so that's that's the length of this parallel side. So you're going to have basically for the first trapezium, you'd have h over 2 times this length plus this length. And for the second trapezium, you'll have h over 2 times this length plus that length. So this length is used in both trapezium 1 and trapezium 2. As is this length used in trapezium 2 and 3. And this length is used in trapezium 3 and 4. And this one is used in trapezium 4 and 5. So this would be the B of trapezium 1 and the A of trapezium 2. And this would be the B of this would be the A of trapezium 1 and the B of trapezium this would be the A of trapezium 2 and the B of trapezium 3. This would be the A of trapezium 2. Okay, this length here. All right. And it would be the B of trapezium 1 and the A of trapezium 2, sorry. And this here would be the A of trapezium 3, but the B of trapezium 2. Okay, because there's one mentioned second for this trapezium and the one mentioned first for that trapezium. Basically, what I'm trying to say here, and not very successfully, is that these lines, these lengths are going to be used twice. Once in the trapezium before them, once in the trapezium after them. So these lines here will be used twice, but the first and the last lines will be used once because there's no trapezium before this one and there's no trapezium after that one. So basically, you're going to have this length and this length mentioned once. Okay, if we call this, for example, y0 and yn, y0 and yn, those are used once, and all the ones between them are used twice. So y1 plus all up to one less than the last one, they're used twice. Okay, so the formula for the trapezium rule is basically based upon that. Okay, and you'll find the trapezium rule formula in the formula book, but it's much easier for you to understand what's happening in this way. So basically, if we work out what this is, you're going to have h, which is the distance between the parallel sides, which is 0.5 divided by 2 times. Then we're going to take the first and the last of these values and add them together. So I have 1.319 plus 1.850 plus 2 times the sum of these, because these are used in the trapezium before and also the trapezium itself. Okay, so we're going to take these values here and we're going to multiply them by 2. So I'll add them together, 1.075 plus 1.001 plus 1.041 plus 1.223. And as I said, these are going to be used, okay, twice. That's why I'm multiplying those by 2. And that will give me an estimate of the answer that we need. So we have 0.5 divided by 2 times, and then I'm going to have 1.319. Let me just have the table there, so in case I've copied down something wrong, I can check from the table. Plus 1.850. I forgot the bracket here. Okay. Plus 1.850. Okay, and then the rest of them, I have to multiply them by 2 after adding them together. So I have 1.075 plus 1.001 plus 1.041 plus 1.223. So close one bracket and close the other bracket and press equals. We get 2.96225. So 2.96225, 2.96225. They want us to give to two decimal places, so you end up with 2.96. Okay, that's an estimate for the integral of this, and there's the answer there for question part B of number 2. Okay, so you end up with 2.96225. Okay, so we know that this is equal to 2.96225. That's what we had to find in part A. I've written that up there. It continues like this. Then it says, use your answer to part B to find an estimate for this. Now, this is the part which is actually something which is really kind of newish since the new P2 has come out. Before this, you didn't really get questions like this so much in the old specification, but almost, every paper since the new P2 has come out, you got part of a trapezium rule question similar to this, where it says use your answer to part B. So what you don't do is use the trapezium rule all over again and make a new table of values and use the trapezium. No, you want to use this answer that I've got written here. That's why I've written it here. You have to use this answer to solve this. So basically what you have to do is try to express this in terms of that. Okay, express this in terms of that. So we want to have an answer for what this is equal to. Now what I can say is if I want to have this and make it look like that, okay, if I want to make this look like that, then what I can do is I think I need to subtract from something. So I can say that basically the integral of this, I can say the integral of between 0.5 and 3 of 1 minus log to the base 10. We don't have to write the base 10, but I'll just write it anyway as they've written it, dx. Now, how does this look like that? Well, of course, I have to take it away from something because I have to end up with a negative log to the base 10. So if I take this away from something, if I have something minus that, so we're going to have integral between 0.5 and 3, I've got to take away what I have there from log to the base 10 sine x. Okay, I've got to take away this from something for me to end up with something that looks like that. Now, I can see that if I take away, if I've got a number 4 here, 4 minus 3 gives you 1, and you end up with, that's going to be 1 minus log to the base 10 sine x with respect to x. So this and this are the same. So these two are exactly the same. Now I have to end up with an expression for the integral of this. That's what I have to find out in the end. Integral of this. So what I'm thinking here is what I can do is I can try to do some rearranging here. Let me first write this as 1 minus log to the base 10 of sine x with respect to x equals, I can split this up into two parts. I can split this up into the integral between 0.5 and 3 of 4 with respect to x minus the integral between 0.5 and 3 of 3 plus log to the base 10 of x with respect to x. Now, I can see that this is the same as what I've got written up here. So I can replace this with 2.96225 to be more precise. 2.96225, was it 225? We've got it here actually. 2.96225, that's right. Okay, I can replace that with this, and that's equal to, well, I can integrate this, that's pretty simple. If you integrate 4, you get 4x. Okay, 4x between 0.5 and 3, minus the integral of what I'm trying to find. I'm trying to find what this is equal to. Now I can do some rearranging, and I can get what I'm looking for. Okay, so I can now make this a subject. So I have the integral of 3 plus log to the base 10 of x with respect to x between 0.5 and 3 is equal to, now if I substitute 3 into here, I'll have 4 times 3 minus 4 times 0.5, and I'll have minus 2.96225. Just, subtract this from both sides. So now I've got something which I can work with here. I know this is what I'm trying to find the value of, and I know it's equal to this, which is 12 minus 2 minus 2.96225. Okay, so you have this, okay, which is going to be a negative, take away 2, and then plus 12, which gives us 7.03775. 7.03775, which to how many decimal places do we want it? Let's see. Okay, they didn't tell us, so I'm guessing we can leave this to 3SF, which we should, which is 7.04 units. That's how we should read it if they tell us, or that's how we should express our answer. If they don't tell us how to express it and it's not exact, you give your answer to 3 significant figures. So there's the answer to part C. Now this is quite important for us to understand how to deal with such questions. All right, and it's not just like something that you can just you guess completely. You have to use some logic. What logic did I use? I knew I had to end up with a minus log to the base 10 because I need to replace an expression. So I had to try to express it in a way that I've got this expression in there, and that's what I did. Okay, so I decided, I realized that the only way to get negative log to the base 10 if you're starting off with this is if you subtract this from something. All right, we need to end up with a 1 here. So 4, if I take away 3 from 4, I'll end up with 1. And I take away this from 4, I end up with minus log to the base 10 of sine x. So that's how we dealt with this question using the answer to part A. So we can split this then into 2 separate parts. And I know how to integrate 4 with respect to x. It becomes 4x. And this part is what I have to find the value of. So I can make this the subject like, I did eventually here. And replace, as I said, this answer to part A with what its value is and rearrange, and you got your answer. So that's how you deal with this question over here. Now, you might want to check to see how close your answer is to the real answer. Okay, you might want to do that. And in order to do that, I'll show you a little trick that we can use. We can go to the original question here, and we can set up a numerical, integration for this. So I can just choose this button here. I can put in my function. I'll put bracket 3 plus log to the base 10, which is the same as log of sine x. Sine of x, so I'll put x there. I'll close the bracket for the sine x, and I'll close the bracket for the log and the bracket for the whole thing. Right, got to be careful about that. And then I'll put the limits in, which are between 0.5 and 3. Now this is going to give me the exact value, which will not be the same as this, but it should be close to this. So we can see we're not very far out. Of course, ours is going to be something which is less, or not quite the same. And why is it going to actually be less? Because if you remember, the curve looks something like this. Okay, something like this. So if we kept it this way, all right, then our answer would be an overestimate, because you can see the trapeziums go above the curve. All right, but this is actually not the same as these two are different. This is what this looks like, okay? But what we've got here, which we actually had to find the value of, this is what we actually found the value of in our calculator, okay, this one. This is compared to this upside down, because this is negative here, this is positive here. So the curve will have that type of shape somehow, and it will also be risen up by 3 units. It'll be something that looks like this, and of course, the trapezium rule is going to give us an underestimate, because this is curving in this direction, and the trapezium will go underneath, the lines for the trapezium go underneath that curve. So the trapezium rule for this particular expression here if we use the trapezium rule, it will give us a value which is less than the actual value, and we can see that's exactly what we've seen here. Okay, so that's a side point that you don't really have to, write about in this particular type of question or consider, but they might ask you, for example, if they give you a curve and the shape of it, is your answer an overestimate or an underestimate, for example? So in this case, this answer, as you can see, is an underestimate, and the reason being because a curve is going to have this type of shape, because it's upside down compared to what we've got because of that minus. So therefore, we can see that we have an underestimate, right? So just the important thing here is, in case you want to make sure whether you got the right answer or not, when you did your manipulation here, if the exact answer that you calculated gives you is very close to your answer like it is, then you can rest assured that you've done the right thing in this procedure here. Okay, so that's something important for you to realize. And you'll see we could have done the same thing here. We could have checked to see, is our answer correct? We could have put inside here 1 minus instead of 3 plus. Everything else is the same. And we should see that our answer is 2.893. So it's, again, close to this, but this is here we have an overestimate, okay, compared to this, because when you have the curve looking this way, if it's going in this direction like this, then the trapezium rule is going to give you a value which is got an extra part there. So it's going to be an overestimate, as we can see from our value. It's an overestimate in this case. Okay, but the next question is upside down because there's a minus in front of it. It's upside down, so we got an underestimate in the last part. Okay, so we got an overestimate in the last part, as I mentioned. All right, so that's how we deal with such questions, and that's a way for us to check to see how close our answer is. Of course, with the trapezium rule, it's not going to be exactly the same. It's going to be close. All right, so I hope that was clear. Okay, this manipulation thing is something which is almost always coming up, so you have to get used to dealing with such questions. All right, so that concludes question number 2, okay, from this P2 paper from June 2022. I hope that was clear. Other questions from this particular paper can be found from the link which will appear in this region over here, at the end of this video. Other questions from this topic of trapezium rule from P2 can be found in the link that will appear over here in this area. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.